Good morning, Dr. Arman.
Good morning, sir. Good morning. Sir, how are you?
Fine, sir. Thank you. How are you?
Sir, I am fine, sir.
Uh,
Sir, can we start or we will just wait for 2-3 minutes?
yeah, as you feel comfortable, I'm okay.
Okay, sir.
Madam, you can start.
Okay, thank you, sir. So good morning, one and all present here, and a very warm welcome to the first session of day 3 of this faculty development program. So for the first lecture, we are already having Professor Dr. Kishore Bhanushali, the eminent speaker, with us. Welcome you, sir, and thank you for accepting our invitation. Now, it is my pleasure to introduce Dr. Bhanushali to the audience. Dr. Bhanushali received his bachelor degree from MS University of Baroda. He also completed master degree in economics from MS University of Baroda. He did diploma in financial management from Ellen Wellinger Institute of Management, Development and Research, Mumbai. Later on, he pursued his doctoral research work under the guidance of Professor B.P. Bhardwaj, School of Social Science, Gujarat University, Ahmedabad. Presently, he is the Director of Academic Administration, United World School of Business, Gandhinagar, and Director of Research, Karnavati University, Gandhinagar. He has been honored with many awards. He is a well-known name as PhD supervisor at various universities. So far, he has published many research articles in reputed journals and book chapters. Not only that, he has also conducted many FDPs as well. Today, the topic of his presentation is hypothesis testing, concept to practice. Now, I would like to request Dr. Bhanushali to deliver his lecture. And before we continue, few housekeeping items. Please remain muted during the presentation. We will have time for question and answer after the presentation, and please feel free to put your questions in the chat box. Over to you, sir.
Thank you, Dr. Roy, for the brief introduction. I would like to take this opportunity to thank ICFAI University, Tripura, Dr. Tapan, who has been coordinating with me, and Dr. Chatterjee, my old friend and like a mentor to me, for giving me this opportunity to take a session on topic of my interest under this FDP program. I would like to thank Professor Dr. Haldar, Vice Chancellor, ICFAI University, Professor Dr. Ranganath, Registrar, ICFAI University, and all the participants for this FDP. I can see the number, total 38, and I'm sure you will be joining us soon. I was just going through the entire schedule. Somehow, because of prior commitment, I couldn't attend the inaugural session, so sorry for that. And the program is abruptly very nicely designed. Rather, it is need of the day, because nowadays every university is talking about research and publications, especially when it comes to various accreditation, including NAC accreditations, where research and publication is something which is very relevant. in under the neck. Out of that 1000 points that you need to score, 250 are for research publications and research related activities. That comes to around 25%, which is a sizable number, and that's where every university is now focusing on research and publications. And I'm very happy that Research and Development Cell under the leadership of Dr. Tapan has organized this program, which is covering very important aspect of research and publication. It talks about research, it talks of publication, and also talk about very important component called ethics, which is need of the day, and it is very important for any academician, because normally in academia nowadays we call either publish or perish. So research is integral part of any academic activity, because people who are doing research, definitely it has a direct impact on your classroom delivery. So the faculty, as a faculty, if I'm doing some kind of research, it will have positive impact on the way classes are handled. It will create you as an identity in academia world. And whether you talk of Scopus, Web of Science, any kind of good journal publication requires a quality research. And quality research include use of statistical tools, software, following ethical practices and everything. So in that context, I would like to really congratulate the entire team for arranging this wonderful FTP. And thank you for giving me this opportunity to be part of this entire process. As per my discussion with Tapan sir and Chatterjee sir, I'm supposed to talk about hypothesis testing, the concept, and also the practical aspect of it. And given this limited time of 2 hours, we want to have some kind of theoretical aspect also, and then we'll talk about a live data. So I've got a sample statistical information also, statistical data, and I'm sure that many of you may be familiar about SPSS, Statistical Package for Social Sciences. Earlier it was a separate company, but now it is under IBM, so we call it IBM SPSS. So we'll be doing hands-on practice with the data set, which is a sample data set available in SPSS, to give you a glimpse of how actually hypothesis testing is really working. For this session, I have prepared a small PPT, but of course we'll not be using a PPT beyond a certain point, because our focus is more on the real-time applications of how this hypothesis testing works. But always theory always beside the application part. So we'll be talking about a theory, and then we'll be talking about application part as well. So let me share my screen. I hope my screen is visible. Can somebody confirm that?
Visible, yes, sir. Yes, sir. Yes, sir. Visible.
Yeah, thank you. This is my topic, hypothesis testing, concepts and practice. As introduced, I am Dr. Kishore Dhanushali. I am working as the Director of Research, Karnataka University, Gandhinagar, Gujarat. And we'll be talking about basics of hypothesis testing. And then focus is, as I said, more on applications. Before we proceed with that, let's talk of briefly about what is research. And when we talk of research, it is very important to talk about the difference between search and research. Okay, because when you say word research, it includes search as well. So search always precedes research, but when you say research, it is something beyond that. Because when you read something on internet, something on Google, something in the library, something published in the journal, something which is taught to you in your classroom, as those theories and all those concepts which are taught to us in the classroom, it is what is there. So it is an existing bunch of knowledge. But when we say research, it is search for a knowledge, search for the knowledge. So we always ask a direct question to anybody comes up with some sort of research outcome, and we say, what is your contribution? Okay, so research is in a way search for a knowledge. This is a new knowledge which is not there with anybody. It is a first-hand information, knowledge that you gain. It is your contribution to existing bunch of knowledge. We call it research. And when it's a research, it is scientific and systematic process. So it is not that you have got some topic, you go to Google, type the topic, read the literature, get the information, and paste it there. It is a scientific process. Scientific process, it has the steps to be followed, and it's a systematic process. If you do not follow the systematic approach, please, can you mute yourself? Yeah, thank you. So it is a systematic process. So there are scientific tools and techniques to be used, and the process is to be followed systematically. If you do not follow systematic approach, you cannot generalize the outcome, and you will end up developing something which is not the expected outcome. And it's like a scientific investigation, like a crime scene. If some crime has taken place, there's an entire systematic process to be followed to arrive at certain conclusion. And it is a careful investigation, systematized effort. And the last line that you can see here, movement from known to unknown. It means something which is known to you, something which is known to the world, something which is already existing. You do that search first. So when I do a literature review for the purpose of my PhD or purpose of writing a research paper, what I'm trying to do, I'm trying to find out what is known. Okay, that known may be in the form of information available in magazine, information available in journal, information available in book, information that I can discuss with my senior, my superior, my colleague. That is something which is known. So first, trying to find out what is known, it is what we call search. And then you try to find out what is unknown. In research terminology, we call it research gap. Remember this term, research gap. So research gap is something which is not known. Okay, not known. It is unknown. So when you do a literature review, okay, you'll get to know what is unknown. And your contribution is to bridge that gap. Something which was unknown to people, you try to bridge the gap through your research. So end of the research, whether it's PhD work or maybe writing a research paper, okay, if you can identify what was unknown and now it is known to you, and to other people by your research, that is your contribution. So just to sum it up, it is a systematic, scientific, careful investigation and a systematic effort towards a movement from known to unknown. That's what our research is. And I'm sure when I'm looking at the schedule, there are people who are going to talk about it much in detail. But to set the 10th tone for our session, I'm just talking about it in a brief. This is the image that I've taken from a textbook. Most probably, if I remember correctly, it is C.R. Kothari. This is an elementary textbook for anybody who is stepping towards a research. And this is entire the research process. The purpose of taking this image is to talk about where our session stands now. Okay, so first is define research problem. So you need to have defined research problem. So what is the research problem that you are trying to find out? Okay, that has to be clear. So defining research problem is the first step. Once your problem definition is clear, at your end, the review of literature starts. And this review of literature has two components. One, review of literature in terms of concepts and theories. So for this, you go to your textbook, talk to people, and be clear with what are the different concepts and theories related to the topic. And then you do a literature review in a systematic manner. In the sense, then you try to find out what work other people have done related to my topic. So if something has already been done, no point in reinventing the wheel. Okay. Say for example, impact of COVID on export and import, or impact of COVID on a certain economic parameter or health parameter. If it has already been done by somebody, why should I do the entire exercise again? That's what a review of literature is. So review of literature is not done for the sake of adding a section in the thesis or article. It is for the purpose of identifying the research gap. Okay, for that research gap, you need to formulate hypothesis. This is what our topic here is as of now. So you have predefined objectives. So based on concepts and review of literature, you have certain objective. One component here is the concept, and for that you have hypothesis to be formulated. Okay, after formulating the hypothesis, look at this. We are not collected the data. We are not analyzing the data. It's the latest stage. Something that I have observed many people commit this mistake. They do not formulate the hypothesis at this stage, and they come to us for hypothesis formation and hypothesis testing once the data are ready. That okay, hypothesis testing will do at a later stage. This is not the correct approach. Objectives and hypothesis go hands in hands. Okay. Second misconception: hypothesis may not be necessary in all the research. The purpose of hypothesis testing is to generalize something. If you want to generalize something based on a sample, okay, we'll be talking about a small story about that to make it much more clear. So in exploratory research, you may not have hypothesis. So after objective and hypothesis, you have to define your research design, including your sampling design, sampling technique, okay, methods of data collection. Then you collect the data. After collecting the data, you test the hypothesis. So remember, hypothesis formulation is before designing the research design. Okay, then you analyze the data. When you analyze the data, you are testing the hypothesis, if any. So if you have the hypothesis, you test the hypothesis. And based on hypothesis testing, the final stage is writing up a report. One more misconception: it is not necessary that your null hypothesis always should be rejected. If it is not rejected, it is also fair enough, acceptable from the research perspective. This is just a brief process. I'm not getting into much detail because our objective is not to talk about that. Our objective for the session, that is next 2 hours, is to find out what is hypothesis, why do you need hypothesis, how do you test the hypothesis, and certain do's and don'ts of hypothesis if time permits. What is hypothesis? When you say hypothesis testing, it is just a probability statement about population parameters. Okay, so it is always a probability statement. That's where those who have done research, we always talk in terms of p-value. Okay, p-value less than 0.05, or sometimes we call it 0.10. Okay, so p is nothing but a probability. So hypothesis testing enables us to make a probability statement about population parameters. Now let's understand what is this population parameter, just for the sake of understanding. I just request somebody, if you want to unmute yourself, you can very well ask a question. Just can anybody tell me what is this? Yeah, please unmute yourself. And what is this? What is this and what is this? Yeah, sorry, I missed out. Yes, what is this? Let me circle it for the purpose, if you can. Yeah, I'm talking about this one. What is this? Anybody?
Sir, population mean.
And what about this one? Next one?
Sample mean.
Okay, is the reverse one. X bar is a sample mean, and mu is population mean. Okay, most of the time when you do research, what you have sample data collected. You selected a sample, data were collected for the sample. Okay, similarly, there is this S, and there is another term called this one. Both are standard deviation. Not getting into statistic at this stage. Okay, this is a sample standard deviation, and this is a population standard deviation. Similarly, we have small n and we have capital N. Now, when I say small n, it's indicate a sample size, and capital N indicates the population size. Okay, so anything which are related to sample. So when you collect the sample data, when you analyze the data, what you get is you get X bar, sample mean, you get S, that is sample standard deviation, your small n called sample size. But your objective was to find out population mean, population standard deviation. Okay, so these X bar, S and N are called statistics, and mu, sigma, capital N and others are called parameters. So parameters are for population and statistics are for sample. So at any point of time, when you want to analyze, uh, sample statistics based on, just a minute, just quickly, I need to turn it off. Sorry, I need to put it. Yeah. So when you want to generalize something about the population based on sample, so you have a population, suppose it consists of say 10,000 people, and from that you selected a small sample of say 500 people. Okay, so based on 500, you are generalizing something about say 1 lakh people. So when you want to generalize something based on sample, you need hypothesis testing. And when you are generalizing this, you are always making a probability statement. Okay, so that's where the hypothesis testing comes in. And it is just an assumption with to be proved or disproved. So hypothesis may get accepted, may get rejected. Normally we do not use the term accepted, we say not rejected. Okay, and it is the formal question that intend to resolve. So you have certain question in mind, you want to resolve it, and it is a predictive statement to be tested by scientific method. Okay, this is what hypothesis part of it. I'll just what these are the characteristics. Just for the sake of reference, I'm not getting in detail. I'll be sharing this entire presentation
Hello.
with sir, and
Hello.
probably yeah.
Hello, sir. Good morning. I'm Tripura. It's a very nice, interesting session. But sir, I have a small doubt, so I thought of clearing it right now.
Yeah, please.
Sir, so we are talking about hypothesis testing, and sir, is it possible in any type of research that a proved hypothesis becomes a hypothesis for another research?
Yeah. See, somebody has conducted a research maybe 5 years back or 10 years back. Okay. Now somebody has found out something. So hypothesis either been accepted or rejected. And now I want to test, I want to recheck. It's like validating the things. Okay, so I can have the same hypothesis or some hypothesis which was rejected by study conducted by you may not be rejected by study conducted by me. Both are perfectly valid, but only thing is you need to justify. Okay, so when you are conducting the research, if hypothesis is accepted or not rejected, if it is rejected in my case, I need to justify what is the reason.
Okay.
Fair enough.
Okay.
Yeah. So what I'll do, I'll come to you. Okay. Now to understand this hypothesis part, again I say this is going to be a story mode kind of thing. Normally we had a storytelling as a teaching pedagogy, and many of you are teachers, so you'll be appreciate that as well. This is a story, and gradually we'll bring it to hypothesis testing part of it. Of course, the story is a bit long, but we need to cut it short. Okay. Yeah, PPT I have stopped sharing, so I'll be sharing the PPT, and you'll have a copy of the PPT coming to you. And after the session, if time permits, we'll share, because as I said, our focus is more on application also. So talking about hypothesis in a slightly different way. This is my own story that I've done. Assume it is midnight 2 o'clock. Midnight 2 o'clock. Lonely area, middle of the road. A person was just passing by, and he was intercepted by a police. So the police one approached him. Midnight 2 o'clock, lonely area. Okay, policeman stopped him, asking a couple of questions. Who are you? Where are you coming from? What are you doing at midnight 2 o'clock on this lonely road? Okay, looking at the police, a person couldn't answer. it happens. Suddenly police catches you and you know the kind of policeman that we have. I started interrogating, where are you coming from and all those things. And the policeman was a bit annoyed. So a person couldn't defend, couldn't answer anything. Policeman thought he might have done some criminal activities. He might have done something wrong. That's why he is not in a position to answer our questions. She was asked to go to police station and was kept behind the bar. I'm repeating just a bit. Midnight 2 o'clock, person passing by, intercepted by policemen, interrogation, couldn't answer the questions, was taken to police station and kept behind the bar. This is one part. In the morning, the same police inspector was reading a newspaper and there were a news about some criminal or non-legal activities, some maybe kind of murder that has happened in that area. Okay. And when he was reading the news, realized that, okay, it was the same area from where that person was caught midnight yesterday. And policeman thought, yes, he was the criminal. That's the reason that he couldn't defend, he couldn't answer. Okay, so case solved. Now, can anybody tell me who will decide whether that person is criminal or not? Feel free. Yeah, anybody? Who will decide whether the person is criminal or not? Yeah, just unmute yourself and you can ask. Yeah, somebody?
Court.
Court. Yeah, so the Roy. In court, who will decide?
Judge.
Judge. Okay, assume you are a judge. On what basis judge takes the call?
Based on the argument of the lawyers.
Not only arguments, something else.
Evidence is also important.
Yes, evidences. Okay. Yes, evidences. Now, if and who will present the evidences? One more thing. Yeah, let's make it open so that I can see. Yeah. Okay. Somebody has written lawyer. Yeah. So, how many lawyers we have in that case? 2. Very good. So we have 2 lawyers. One, public prosecutor, who is trying to prove that he is criminal and should be punished. Other is defense lawyer, trying to prove that he is innocent and should be released. Okay. Now, both the lawyer, just to prove that argument, prove the point, they'll present certain evidences. Which evidence they'll present? Both the advocates, they will present only evidences which are in their favor, because ultimately they are advocates. So they'll present an evidences which are in their favor only. Now you are a judge. Assume that you have 100% evidence. I'm saying population of evidence. 100% evidences if are available to you, what will be your judgment? Your judgment is bound to be 100% accurate. So if 100% evidence are available, your judgment is bound to be 100%. But you are not presented with 100% evidence. You are presented with selected evidence from both the parties, both the lawyers. So what you have? You have sample of evidences. Getting a point? Sample of evidences. So here, your judgment is not based on population of evidence. Your judgment is based on sample of evidence. And when you are making a judgment based on sample of evidence, your judgment may go wrong. Okay, so there are 4 possible situations. There are 4 possible situations. Situation number 1, I'm assuming because when I'm looking at the name, I could see a couple of people with a doctorate as well, and many of you are in teaching fraternity, so you're able to understand things in slightly a better manner. There are 4 possible options. Option number 1, person was innocent. Person was innocent, and based on sample of evidence, you gave your judgment that person is innocent and should be released. This is correct judgment. Other one, other extreme. Person was criminal. He has committed that crime. He has, okay, he has committed that crime, and based on sample of evidences, you give a judgment that is criminal, should be hanged. फांसी की सजा सुना दी गई. Again, correct judgment. So these 2 are correct judgment, but then there are 2 other wrong judgment also. Okay. Wrong judgment number 1. Person has not committed a crime. He was innocent, but since evidences were against him, you gave a judgment to be hanged, to be punished. This is wrong judgment. Other one, he has actually committed a crime. He was criminal, but based on sample of evidence, you gave a judgment that he's innocent and should be released. So there are 4 possible situations, 2 correct judgments and 2 incorrect judgments. Why you have those 4 possible situations? Because you are giving your judgment based on sample of evidence, not based on population. Similarly, when you do research, okay, if you have collected the data from entire population, if the population is small, okay, it is possible to collect the data from entire population. Suppose, say currently we have 85 members in our group, and our project is very simple. We want to find out an average age of our FDP participants, and everybody is available here. If we start asking the age data, everybody gives the age, and if I find out an average, okay, my average is bound to be 100% correct. Say for example, our population is of around 85 people only. We are talking about finding an average age of FDP organized by ICFAI University Tripura, okay, during this period from 16 to 20. So 5 days FDP period, we want to find out an average age. So we collected the data, asking everybody what is your age, collecting the number, and suppose that average age turns out to be 32.5. So I go to the Vice Chancellor and said, sir, Dr. Halder, average age of a participant is 32.5 years. And if our Vice Chancellor says that I do not agree, I'm trying to make it as simple as possible. If my Vice Chancellor says I do not agree, so my counter argument is, sir, if you do not agree to that, you can revalidate. So the same project is given to Dr. Tapan, okay, to find out an average age of the FD participant. So Dr. Tapan has again collected the data from everybody, all 85 people, computed an average. His average again turns out to be 35.5. Mine was 35.5. His is 34.5. If the same project is repeated 100 times, okay, everybody will comes up with the same number, 34.5. It means when I'm making my judgment based on population, so there are 85 people, I cover everybody. So when I'm saying average age of the group FDP participants is 35 years, I am 100% correct. Am I audible perfectly? Somebody?
Yes, sir.
Yeah, thank you. So I'm 100% correct. If the same project is repeated 100 times, everybody will come with the same number. Everybody will come with the same number. It means when based on a population, sorry, I need to put my phone on a silent mode. Yeah. So when I conduct my research based on a study of entire population, my confidence is 100%. 100% confidence. It is 35.5. It means if you repeat the study 100 times, everybody will prove me right. That's what my level of confidence. Besides, provided I have done a research for the entire population. But suppose the project was not about this FDP for ICFAI University Tripura during the 16 to 20. Okay, it was general FDP all over Tripura, all the universities. And these 85 people represent a sample. Now, when I selected a sample, so there were around say total 5,000 people have participated in different FDP in different universities. I've selected a sample of say 100 people or 200 participants and collected an average age. Now that average age for me turns out to be 32.5. But the same project, if repeated by Dr. Tapan, collecting the data from 100 or 200 participants as a sample, he may get a different number. And if the study is repeated 100 times, you will have 100 different results because everybody is working on sample. So when you are working on sample, you need to test the hypothesis. So remember, when you are doing a population study, the question of hypothesis testing doesn't come in. The question of hypothesis comes in when you are selecting a sample. So your judgment based on sample, is it validated? Is it applicable to entire population or not? Then only the question of hypothesis testing comes in. Back to our criminal example. Okay, now there are two correct answers. There are four answers because I am doing a judgment based on sample. If it is based on population, there is only one correct answer, no other correct answer. Based on sample, there are two correct answers, two wrong answers also. Now, which one is more dangerous? I'm repeating those wrong answer again. Person was innocent but released. Second, person was guilty. Person was innocent but penalized. Other guilty but he was released. Which is more dangerous? Can anybody tell me? This is very important concept that we are focusing on. Punishing the innocent and releasing the guilty. Which is more dangerous?
Punishing the innocent.
Punishing an innocent. So if the person was innocent, if I give a judgment to hang, there is no way, no way I can correct it. Okay, but if he was guilty, but based on evidences, I released because evidences were not in his against. Okay, so I couldn't prove that he's guilty, so I released him. So what? He's a criminal. So he's in the society, will be committing crime again will be caught. So there are possibility of reopening the case as well. So if innocent is punished, no way you can correct it. It's more dangerous. So when you do a research, when you read a literature, when you are testing an hypothesis, we always talk of that p value. And mostly we said p less than 0.05, hypothesis rejected. P greater than 0.05, hypothesis is not rejected. Okay, this is that probability value. Probability of punishing innocent. Okay, in statistical term, in research term, we call it type 1 error. Now, in specifically in legal fraternity, whether and the other error is called type 2 error. So read something on type 1, type 2 error for the better understanding. Okay, so more dangerous is type 1 error. We want to minimize that. Now, any kind of error can take place, but we want to minimize type 1 error. And just to make sure that type 1 error is minimized, we have provision in our legal framework, okay, which said 100 criminal may be released, but there should not be punishment for a single innocent person. Okay, that's what a provision is there in the law itself. Similarly, Similarly, when we are doing a research, there are likely chance of me committing type 1 error.
Sir, I have a hello.
Yeah, Konark.
Konark, yes, sir. Sir, good morning. Sir, I want to tell you something. I have a doubt because see here the convicted person. Here I have to take two hypotheses, right? Here the null hypothesis will like that the person is no guilty. The convicted person is no guilty will be my null hypothesis, sir. Right, sir?
Yeah, see, you have null hypothesis and alternative hypothesis both. Now, null hypothesis is called null because if it is accepted, no action is required. So in this case, if the person is innocent, proved innocent, no action is required to be released. Action is required if it is guilty. So if innocence is not proved, he is guilty. So what I'm trying to do, I'm trying to find whether he's guilty or not. But my hypothesis is innocent. So unless proved guilty, he's innocent.
Actually, sir, I want to know. Now I will take another hypothesis here. That is my alternative hypothesis. That the person is person will like another criminal. He is he is not guilty and something like this. Sir. He is guilty. So I want to know now if I find something which is not exist, it is more dangerous.
No, Konark, just to update you. In research, we do not work on alternative hypothesis at all.
Yes, sir. Yes, sir.
What we work on, we have null hypothesis. We try to check the null hypothesis. Okay, that's the reason I say that in research, now we do not call null hypothesis accepted.
Yes, sir.
We say we do not have evidence to reject it. Okay, so when you do a testing, you test only null hypothesis. That is nothing to do with alternative hypothesis. And now in most of the research that we do not even write alternative hypothesis. So we are null hypothesis to be tested. If it is null, is rejected. So I was trying to prove whether it is innocent or not.
Yes, sir.
Okay, it is. If I couldn't prove that it is innocent, it means he is guilty. So alternative automatically comes in, and when you do work with the real data, you'll have better understanding for that as well.
But sir, if I'm saying that in the eye of justice, it is more serious to find difference, who is guilty.
No, but that's what I'm saying. You wanted to prove whether he is guilty or not.
Yes.
Okay, so you wanted to prove whether he is guilty or not. But your null hypothesis is not guilty. If it is not proved, then automatically guilty comes.
Yes. Yes. Thank you, sir.
And when you say null, it means no action is required.
Yes.
Alternative means if it is not accepted, then alternative automatically comes and play the role. Okay. So when you work with those type 1 error, and when I say that I'm not 100% confident. So if study is based on population, my confidence is 100%. So chance of error are 0. Provided I'm conducting a census. Census means covering entire population. But in real time, we do not have entire population available to us. So we go with a sampling because covering population sometimes is not feasible, probable, okay, possible. Plus, we have a resource constraints in terms of money, in terms of time, in terms of manpower. So in order to maximize, optimize the resources, rather than conducting a census, we conduct a sample. When you are conducting a sample, there are chances of committing an error. Okay, and you need to define what percentage of error are acceptable to you. What percentage of error are acceptable to you, or in other way, what level of confidence you want to be. In census, I'm 100% confident. But in sample, I cannot be 100% confident because answer varies from sample to sample. So we have to decide well in advance. What is the level of confidence that you need? In social science, we work with 90%, we work with 95%. But if it is a medical science, something like that, we cannot even take a chance, and we want to be 100% confidence for any kind of experiment that we do. Okay, so when I say I want 95% confidence, it means 5% chance of committing an error. Okay, so it means when I say that null is rejected, null hypothesis is rejected, H0 is rejected, there are 5% chance of me committing that error. Is what not supposed to be rejected, but I rejected it. So that is 5% chance of committing an error. Now when I say 5%, it means 5 by 100. It is 0.05. So that p value 0.05 is nothing but probability of committing type 1 error. In a way, probability of punishing innocent. Okay, that's what hypothesis testing comes in. So that's where the the role of hypothesis testing comes in. And hypothesis testing has certain procedure to be followed. So I'll just take you through a small part of my presentation. These are something which you can read through, will not be this in this null hypothesis, alternative hypothesis, this FTP. So assuming that you know bit of it, this is what a level of significance. Okay, so when I'm talking about this 5%, okay, so it is 5%, so it is 5 by 100, so we call it 0.05. You can have 10%, so when I say I'm 90% confident, and whether it is 5%, 10% is purely at the disposal of researcher. These are type 1, type 2 error. You can skip this as of now. Yeah, this is the procedure to be followed for hypothesis testing. Number 1, making a formal statement. So you need to make a formal statement. Now this statement should be such which is testable, So first you prepare an hypothesis. So here I'll make H0, I'll make H1. So H0, H1s are prepared here. Then selecting a significant level. Okay, significant level. So I decide whether I want 5% significance or 10% level. See, I have not collected the data. This is to be decided in advance. So my hypotheses are decided. Significance level is decided. Then distribution to use. Now here, when I say distribution to use, we have T distribution, we have Z distribution, we have F distribution, we have chi-square distribution. There are various distribution to be used. So you have to be very clear in terms of which distribution you are going to use, and we are going to talk about it when we are working with the real-time data. Okay, after distribution to be used, you have to compute the appropriate value. So you compute the statistics. So if you are using Z distribution, you compute Z value. If you are using T distribution, you compute T. When you're working with chi-square, you calculate chi-square. If you're using ANOVA, we can use F-test. So calculating this value. In our college days, we had a textbook for statistics. Backside of the textbook, we had a Z table, we had a T table, we have F table. So we used to compare the calculated value with the tabulated value. But now since we have the software, those tables are not required. Software straight away gives you a p value and you can straight away do that interpretation part. So use of the software is only for calculating the value. Okay, calculation of probability software, p value software will calculate. Only your role is compare the probability. It means your probability, you are ready with a p value of 0.05. Software gives you actual probability. This is your acceptable probability. Software gives you actual p value. You compare that p value with your value and take that decision. Okay, that's where the procedure comes in. Let me stop and I'll continue. Clear? So this is what broadly. Now, just to reiterate again, one more example from my side. What this hypothesis testing part of. Again, a small story. I was not feeling well yesterday or day before yesterday, having kind of feverish, not comfortable physics. So I go to my doctor, my physician, family physician, and said, "Sir, doctor, sir, I'm not feeling well. I hope something is wrong with my body. What doctor does? Doctor take up the stethoscope, check the heartbeat, ask me to take out the tongue. Okay, check the eyes, color of the tongue, temperature, pressure. Okay, he do the preliminary examinations. And after preliminary examination, he said, sir, it's look like a dengue or look like a malaria. Okay, he will not tell me whether it is dengue or malaria or COVID. He said, it looked like a malaria, it looked like a dengue, or look like a COVID, or look like a typhoid. How do we prove whether it's malaria or not, or dengue or not? How do we prove? For that, he will take out a piece of paper and recommend me certain tests. So what I need to do? I need to go to laboratory with that piece of paper. Okay, when I give it to a laboratory person, he takes up the sample, either blood or urine, maybe whatever experiment that we need. Okay, and that test will prove whether it is dengue or not, whether it is malaria or not. Okay, so Priyabatra, yeah, sorry, thank you. If you have some question, feel free. Yeah, sorry. In order to prove whether it is dengue or not, COVID or not, okay, he will ask me to go for a laboratory test. Now in labs, whether they will do a blood test or what kind of test they will do, that depends on the disease that is expected. So for a dengue, it is a different test. For malaria is different. For COVID is different, and so on and so forth. Similarly, when you are doing a research, when you are testing an hypothesis, which tool do you use differ based on objective, based on data. So whether you use Z test, whether you use T test, whether you use chi-square, whether you use F test, it depends on your own objective, the kind of data that we have. So we have a different statistical test for different objectives. Based on when you have that test result, you again go to a doctor and showed him the result. And always there is a parameter for a normal range and then actual statistics. If your actual RBC or WBC is in that accepted range, doctor said everything is fine. If that calculated value, okay, RBC, WBC, what it may be, is beyond certain number, outside that acceptable range, it proves that you have a medical illness, either COVID or typhoid. Okay, so any medical test that you conduct, there is always a range mentioned in the report. As long as the actual value lies in the range, it is okay. But it's beyond the range, then you say that yes, you have proved that something. The same thing applies when you do hypothesis testing in real data time. Okay, where you have a p-value, level of significance, level of confidence decided well in advance. When you run a statistical test, you get actual p-value, and if that actual p-value is less than accepted p-value, you reject. If it is more than that, you do not reject. Rest we'll talk about when it comes to real data. Now, any question at this stage before we go with the real-time data? Sorry, a sample statistics that we have. We'll be really doing hypothesis testing. Any question with anybody at this stage? Feel free. We can take up a minute or so.
Sir, hello.
Yeah, Gonak.
Sir, while doing research, suppose I'm committing error, type 2 or type 1.
Yes.
So which one should be more serious, or which one should be less serious? Suppose if I say type 1 is much serious, I think, and type 2 often taken as less serious. Is it
yes,
true, sir?
when you do research, we always work with type 1 error only, which is more dangerous.
Yes.
Okay, and when we when we ask that p value, p is probability of committing type 1 error.
Yes, sir.
Okay, so we work with type 1 error only. Okay. Let me share my screen. Okay, before that, how many of you are aware about a software called SPSS? I am sure many of you might have used by now. So yeah, thank you. So at least we have few people. So I'm sharing my screen with my SPSS as a data file. I need to move this somewhere. Yes. Okay. This is a data file. And just to give you a background so that we'll do, both of us will be at the right page. This data pertaining to, this is a hypothetical situation, hypothetical story. Data pertaining to a company. This is a multinational company having branches across the world and having around 6 lakh plus employees or 60,000 plus employees. 60,000 plus employees across the world, multinational company, and company recently has started getting allegations. I'll strongly advise focus a bit here so that you can understand how hypothesis testing is done in real sense. Okay, repeating again, multinational company, 60,000 employees spread across the world, started getting allegations from the market. So there was a media news, something like that, that this company is having gender bias. Now, when I say gender bias, it means female are not paid at par with their male counterpart. So female ka salaries kam diya jata hai. So females are paid less when compared to their male counterpart. Or when it comes to promotion at a senior position, female are not promoted at par with their male counterpart. So this is an allegation that market had. Second allegation was this company is having a minority bias. Now, when I say minority bias means the Americans are in non-minority. So non-Americans are minority group. Being an American company, large number of employees are American, but there are non-American employees also. So Americans are paid slightly higher salary when compared with non-Americans. That is minority. When it comes to promotion, non-minorities are not promoted at par with the localized people, American one. These were the allegations. With this allegation in mind, company approached you as a researcher to find out the truth. Because being an American company, they had a non-discrimination policy. So such kind of discrimination otherwise are not acceptable, not as per the policy. But since recruitment is taking place, salaries are decided at a different branches across different countries, there are likely chance of this allegation being true as well. Okay, so you are hired as a researcher to find out the truth. So this is a project that you have at your disposal. Now, as a researcher, you have two options. Option number one, conduct a census. Conduct a census, it means you collect the data from all 60,000 employees about the salaries, about the minority status and everything, and give the result. Since you are collecting data from all the employees, we call it a census approach. Census. You conducted a census, and when you conduct the census, you find out an average salary of male employee, average salary of female employee. If there is a difference, you prove that yes, there is a bias. You collect the data about the designation of male and female and present to a management, and you can really prove whether the bias is there or not. And when you do that, conducting census, you are bound to be 100% correct. There are no chance of committing any error. But that requires a lot of effort in terms of approaching those 60,000 people. You need a lot of manpower, collecting data from all those people, analyzing it. It requires data, doing data entries and everything. it required a lot of resources, manpower, money, and also time as a resource. So decided to select a sample. So we selected a sample of around 400 employees, randomly selected, not getting into sampling technique again. Randomly selected 500 employees, you share the data. Design the questionnaire. So instrument was designed, data were collected from all those 500 people. Some of them have not responded, so those people couldn't be approached. So whatever number that you can collect, you have analyzed the data. Now, what question you had in the questionnaire? Okay, for that, we need to understand. Assuming that space is basics is known to you, I'm just going to a variable view. What question you had in the questionnaire? One, employee ID, which is just a serial number. Then you ask the question about gender. In gender, you have two variables, female and male, and coded as F as female, M as male. Because this is an American company, not an Indian company. In India, normally we code it at 1, 2 or 0, 1. Okay, this is an American company where you, if you give 1 to male and 2 to female, itself will be treated as biased. Okay, so they have coded as M for male, F for female. So that's the information about the gender. You collected the data about the date of birth. You collected data about education in years. How many years of education a person had? You have collected data about employment category. Here we have 3 categories. 0 is missing. If somebody has not responded a category, you mark 0. 1 is clerical, so lower level job. Custodial is a middle level job, and manager is a senior level job. So whether you are at the clerical level, that is junior level, middle level, and upper level. So that was this post. Then you collected the data about current salary, beginning salary, month since hire, since how many months you are working with this company, previous experience, what was the previous experience in terms of number of months, and you also collected the data about minority. So if somebody is not revealed the status, you mark 0, 1 for minority, okay, sorry, 0 for non-minority, 1 for minority, and 9 for missing. If somebody has not responded, you mark them as 9. With that in mind, data were collected and data entry has been done. Data entry has been done. Okay, and now what you have? You have data about serial number, gender, date of birth, education, job category, salary, beginning salary, job time, previous experience, and minority. Data are collected and you are analyzing the data. Normally we had a multiple stage process. We call it univariate analysis first, where you analyze each variable one by one. Then we get into bivariate analysis, where we with 2 variables and analyze them. And then we get into multivariate analysis also. Okay, but since our topic here is hypothesis testing, we are talking about hypothesis testing only. We can have another FDP for entirely on data analysis using SPSS, and many of you might have done it, or you may be aware about that. So here, my objective was, now bit focus. My objective was to find out whether there is gender bias or not. Now, my objective, see the way we write objective. My objective was to study gender bias in terms of salary. This is a qualitative statement. So objective is always more of a qualitative statement, not the hypothesis. Now, based on that objective, I need to frame hypothesis, null hypothesis and alternative hypothesis. Here, my null hypothesis is, because I am talking about 2 variables, salary and gender. So my null hypothesis and the hypothesis should be quantifiable, testable, quantitative terms में होना जरूरी है. So here my null hypothesis is there is no significant difference between the salary of male and female employee. I'm repeating, there is no significant difference in the salary of male and female employee. This is my null hypothesis. If it is rejected, my H1, there is a significant difference. So null hypothesis always in no significant difference. It means status quo. Because if null is accepted, that yes, there is no significant, we couldn't reject the null hypothesis. If there is no significant difference, it means no action is required. Okay, but if it is rejected, that we can prove that yes, there is a difference in the salaries of male and female. It means null is rejected. If this null is rejected, it means some action is required. So if there's a difference in the salaries of male and female, some action is required from the management perspective. Some policy actions are required. Somebody has to check why there's a difference, what can be done to minimize this, how it can be corrected, because it is going against the policy. So when it's a null hypothesis, it means when null is accepted or not rejected, no action is required. Alternative hypothesis requires an action, some justification, some logic, some reasoning. Okay, so here my null hypothesis is there is no significant difference in the salary of male and female employee. And alternative one, there is a significant difference in the salaries of male and female, or salaries of male and female. So here, what I have got two kind of data, or I need two data for this hypothesis. Now, if my hypotheses are written in advance, I know what kind of data are required. Now, for this hypothesis, I need two kind of data. Number one, I need data about gender, whether the respondent is male or female. Second data I need is about salary. So while designing a questionnaire, while designing an instrument, I'll collect the data about these two variables. If I not collected any of this data, I will not be able to test the hypothesis. This happens when somebody comes to us for the guidance and said, sir, I want to test this hypothesis. And we look at the data file, the person has not collected data which are required for testing an hypothesis. That's where we suggest that hypotheses are to be decided in advance. Okay, now here I have got the data about gender. So this column I have got data for gender. This column I have got data for salary. Now here, let me stop sharing. Yeah, those who have pen and pencil or not pen, they can mark it up. Okay, something that is very relevant for you, which will help you in identifying which test to be used. Okay. Somebody is writing a question. One way ANOVA, of course, we'll be doing that. Nitish, that's where our role is. Yeah. So one, variable are of two types. I'm just trying to make it more simple. Variables are of two types. One, category variable. Category variable. Other, continuous variable. Now, if you look at our data file, we have variable called gender. Now, gender variable, I know well in advance that either it is going to be male or female. So I got two categories. Okay, so gender is a category variable. If about designation, job category, I know well in advance it can be clerical or custodial or manager. So I know three categories. I know well in advance that what value it can take. So when I can define well in advance the values, I know value in advance, that variable is called category variable. So I can have two category, three category, five category, depending on the kind of data that we have. That's the category variable. But the other variable that we have, say salary, I have not grouped it. So it can take any value. I do not know what value will come in that column. So the variable where we do not know value in advance, that variable is called continuous variable. This difference is very important to do a basic hypothesis testing. Otherwise, you'll end up creating mess. So if variable can take any value, it is a continuous variable. If variable can take only selected values, it is category variable. One more example. Suppose we are collecting the data about age. There are two ways to collect the data. Number one, in my questionnaire, I have got column age and then column and there is a space. You can mark any age. So then variable can take any age. Somebody may write 35, somebody write 36. Between 30 and 35 and 36, there can be 35.5. Between 35 and 35.5, there can be 34.1. So age becomes a continuous variable. But suppose I have asked the question in slightly different format. Age, then one box saying up to 20, 21 to 30, 31 to 40, 41 to 50 and above 50. So now I know that I have got 4 categories in a age. This becomes a category variable. So whether you are talking about continuous variable or category variable, this is very important primary work to be done before you go for hypothesis test, and then collect the data accordingly well in advance. Okay. Now there are multiple options available. You are dealing with 2 variables because hypothesis required at least 2 variables. When both the variables are category variable, you use chi-square. Somebody call it chi-square. So 2 category variable, we use chi-square. I'm just sharing a screen for the better understanding. Suppose I'm talking about 2 variables, gender and other variable I have got job category. Okay, so I want to find out how many male manager are there, how many female manager are there, how many male supervisor is there, clerical male, percentage of male and female across different categories. So I'm talking about 2 variables. One is gender and other is job category. So gender is a category variable because I have got 2 category, male and female. In job category again is a category variable because I have got 3 category. So when I'm analyzing this 2 category variable, statistical test to be applied is called chi-square. Chi-square, somebody call it chi-square. Okay, that is one. We'll be doing it up online. Okay. So, okay, something is there. Okay, in chat box. Yeah, Anova will do it. This is one. Second, suppose I'm analyzing 2 variables. Here I have got salary and here I have got gender. Salary and gender. Now I have got 2 variables. One is gender, other is salary. Now here my variable 1, salary, is a continuous variable. But another variable is category variable. So one is continuous variable, other is category variable. But here in category variable, I have got 2 categories. 2 categories. So here, when you are dealing with 2 variables, one is continuous, other is category variable with the 2 category, you use the statistical test called independent sample t-test. T-test. So t-test is applied here. Okay. So t-test comes in. Suppose third one. I'm talking about salary, which is a continuous variable, and job cat, which is a category variable. So one continuous variable, one category variable, but here in this category variable, I have got more than 2 categories. More than 2 categories. So when you have one continuous variable, one category variable with more than 2 categories, you use F test, F, which is nothing but ANOVA. Suppose asking a question, this ANOVA, we'll be doing that, ANOVA. So F test is applied here. So chi-square, T test, F test. Okay, third one. Suppose I'm trying to find out, is there any connection between salary and education? Here education of course is a continuous variable, or I'm talking about a connection between salary and beginning salary. So the person who was hired at a higher bigger salary, are they getting higher current salary now? Now here I am talking about two variables. Both the variable are continuous variable because both the salary can take any value, salary beginning can take any value. I do not know what value it will take. So when I'm talking about two continuous variable, we do a analysis called correlation and regression. Correlation and regression. Okay, so remember chi-square, t-test, ANOVA, correlation, regression. Something that probably we'll be planning for next half an hour that we have. Any doubt with anybody at this stage before we proceed with analysis? I'll be sharing the sample file also, and probably you'll have the other detail coming to you as well. Any question at this stage with anybody? Feel free, either write in the chat box or you can very well pose a question. Pratyush will be doing ANOVA, one way ANOVA only. Should we move ahead? Of course, we got more than 100 people now. Should we continue with analysis?
I think
Sir.
yes, sir.
Yeah, thank you.
Sir, I have a question.
Yeah, Priyam.
Sir, suppose I collected the data using any ordinal scale. Is it possible to do t-test, ANOVA?
Priyam, when say ordinal scale, if it is a Likert kind of scale, Likert scale.
Yes, sir.
Yeah, if it is Likert scale, first you need to check the reliability of the scale, for you use Cronbach alpha. Okay, and Likert scale data are used both category as well as continuous. So you can use it as a category variable also, and you can use it as a continuous variable also. Both the way are possible. Okay. Let's move on with the analysis. Now here, the first thing I want to find out, I want to compare the salaries of male and female. Now here, I have got salary, which is a continuous variable. I have got gender as a category variable with two categories. Now here my hypothesis is there is no significant difference in the salaries of male and female. Okay. Now why we use this word significant? Because whatever number that we get are for the sample only. Okay, the difference may be because of sampling error. We want to check up whether the difference is because of sampling error or difference is there in the population. That's where the word significant comes in. So we are using testing the hypothesis using a sample data, employee data file, which is a sample file available with every SPSS. I'll go to analyze. We have tab called compare mean and independent sample t-test. Okay, just for the sake of reference, I have already prepared many videos related to this kind of analysis. Okay, and those are available on my YouTube channel as well. So I'll be sharing the detail after the sessions, and those live recorded videos are also available. And I think this session is also getting recorded, so you'll have something coming to you. So independent sample t-test. Because we selected two samples, one sample of male, sample of female. Okay, that's why we want to find out the test variable. This is a dialog box. Which one to variable you want to test? You want to check the variable current salary, and you want a grouping by gender. So you have salary group by gender, that is male and female. You need to define the group. So you have two groups. One was F for female and M was for male. If you have coded like 01, you put 01, 12, put 12. Continue. In option, it asks you, look at this. Confidence interval. What consider confidence you need? So when by default is 95, it means I'm okay with 5% chance of error. It means when I say there is a difference, I want to be 95% confidence. So there are 5% chance that there is no difference, but based on sample of evidence, I say there's a difference. So I want to be 95% confident. This you can change it to your level of 90 or so. And pressing OK. Now we have the result. Okay, just to update, how does it work? Number one, this is the group statistics. What does it tell you? It tells you that in a respondent that you had, there are 216. Okay, this number 216 female and 258 male. So these are number of male and female in the sample. Average salary of female is around $20,000. Average salary of male is around $41,000. So there's a difference. So it seems that male candidates are on an average getting 41,000. Female candidates are getting on an average 26,000. So there's a difference. Now this difference between salary of male and female could be because of two reasons. Slight attention is required. This difference could be because of two reasons. Reason number one, there is a difference in population. So if you selected a sample of 60,000 employees, there was a difference in the population. So there was a difference in the sample. So is difference is there in the population, so it is there in the sample. That is number one. Other reason is there is no difference in population, but since you have selected a small sample, I think it is 474. Yeah, total sample is 474. Since you have selected a small sample, okay, sample to sample number are bound to vary. So difference is so small that it is just because of sample. Now, when you talk about a difference in the sample, the difference may vary slightly. So want to check whether this difference is due to sampling error or it is there in the population. It's like whether the symptom that I had are for typhoid or not. So what you do? You need to go to lab. Now in lab, depending on the disease, there are different laboratory tests. Similarly, depending on the kind of variable, there are different statistical tests, and there are large number of tests, parametric, non-parametric, and within each category there are large number of tests. Okay, so here, since we are dealing with one category variable with a two category, one continuous variable, as we have written just right now, the relevant test applicable here is t-test. Okay, so we have independent sample t-test done here. Okay, and that independent sample t-test tells you whether there is significant difference or not, and for that you need a p-value. Now p-value that you have defined in advance is 0.05 because you wanted 95% confidence. You are ready as long as your error is 5%. So you reject the hypothesis, okay, and prove that there is a difference. You are okay with 5% error. What software does? If it is not the software, you do a manual calculation. So there is formula to be applied. You do a manual calculation, and with this much of large chunk of data, it is nearly impossible, or it takes a lot of time for you to collect the data. Sorry, to analyze the data. So you have a software at the disposal. Software gives you a ready-made outcome. What software gives you? Software gives you actual p-value. This is significant value, and this value is 0.000. So you call, since p-value is less than 0.05. Okay, so this is a p-value. since this p-value is less than 0.05, okay, it means you reject the null hypothesis. And the null hypothesis that we framed was there is no significant difference. It means male and females are getting equal salary. That S0 is rejected because you got a p-value which is less than 0.05. Suppose, just for the sake of reference, if my p-value is 0.250, what's the difference? Now, when I say p-value 0.000, it means my level of confidence is 100%. I'm 100% confident. There is no chance of committing an error. So if I reject the null hypothesis, that male and female are getting different salaries, there is a significant difference in the salary of male and female, I am 100% confident. If the same study is repeated 100 times, everybody will come to the same conclusion. If the study is conducted covering entire population, you will arrive at the same conclusion. It means I am 100% confident. But if the p-value is 0.250, now if it is p-value is 0.250, we do not reject the null hypothesis because now we say p-value is greater than 0.05. Okay, so when p-value is 0.250, okay, my chance of committing an error are 25%. So if I reject the null hypothesis and say that there is a significant difference in the salaries of male and female with a p-value of 0.250, which is nothing but 25%, it means my level of confidence is just 75%. And I'll be committing an error of 25%. There are 25% chance that I'm making wrong judgment. I'm making a wrong conclusion about population. What chance of error ready to accept is 5%. I'm okay with 5% error. I'm okay with 10% error. Okay, but here chance of error are 25%. So I said we do not reject the null hypothesis. But in our case, we reject the null hypothesis. We reject the null hypothesis because these are p-values. This is how hypothesis testing is done in case of independent sample t-test, one continuous variable, one category variable. Any question at this stage? Anybody? Yeah. Should we continue? Yeah, thank you. Now going back to the data again, need to close the annotations. Yeah. Going to data file again. Sorry, let me clear. Okay. Yeah. So going to data file again. So one, we could prove that there is a gender bias. Objective was to check whether gender bias is there or not. And using the data, we proved that yes, there is a gender bias. Now, other gender bias could be in the form of job category, the position. In order to check that gender bias, we need two variables. So I got one variable gender here, other variable job category here. Now I have got two category variable. And just you have written in the notebook. When you're talking about two category variables, the relevant statistical test that is applicable is chi-square. You call it chi-square. How chi-square is done? Now here, the null hypothesis for chi-square is slightly different. So what is your null hypothesis in this case? Your null hypothesis in this case is gender and job category are independent. I'm repeating. Gender and job category are independent. It means gender has nothing to do with job category. If it is rejected, it means gender and job category are not independent. This is how null hypothesis is written. You might be aware about APA style, American Psychological APA style. We remember APA style as a referencing style. But friends, APA has a style for reporting the result. So when you do a chi-square or t-test or ANOVA, how do we report that in your thesis, in your paper? There's an APA style also. The advice refer to that as well. Here we are talking about two category variables, so we go with chi-square. How chi-square is done in SPSS? Analyze. There is tab called descriptive statistics, and here we have a tab called cross tab. Cross tab because it gives you a table with two variables, one measured in the columns, other is measured in the row. So row variable and column variable. Define the variable. So I selected gender as a row variable. So I want row for male, row for female. I want employment category in the column variable. So I'll have 3 columns. So I've got 2 row, male, female, 3 column, clerical, custodial, and manager. So I got the table. Okay. So you select row and column. Then here we have a tab called cell. Cell. Because every column, every row column gives you a cell. Now, one important variable here is there's a percentage here. So I want percentage by gender. So gender is measured in row. So I'll select row here. Just pressing continue. And we have a tab here called statistics. I click on statistics and there is a chi-square here. Chi-square. Continue and pressing OK. This is what my result is. Just doing it again for the sake of it. Okay. Yeah, this is a cross tab. Okay. This is a processing summary. So it tells you that total 474 cases were processed. There are no missing number and total 474s are taken into account. Now this is my table. What does it tells me? Let me go with annotations. If you can highlight. Yeah, just a minute. Yeah. Okay. This is a cross tab. So I have got male, I have got female. So male, females are measured here. Clerical, custodial, and manager. Okay. Now we have selected percentage by row. So what we have? We have 100%. So out of total female, 95% female are doing clerical job. 0% female are doing custodial. So there is no female at the middle level. So and 4.6% female are at the managerial positions. It means out of total female, only 4.6 percentage of female are promoted to a higher level. When I look at the male, 60% are doing clerical job, 10% custodial, and 28% manager. So when you look at this data, these data represent a sample of 474. Okay. Now, when you look at the data, it looks like that there is gender bias. It's like doctor test you and said it looked like a dengue. So here the data look like a gender bias because 95% female are doing clerical job against 60% female. Sorry, male. For 28% male are doing managerial role compared to 4.6% of female. So if you are a female candidate in this company, there are 4.6% chance of becoming a manager. But if you are a male candidate, there are 28.7% chance of becoming a manager. So it looked like a gender bias. But whether this gender bias, the data, the difference in number, which are visible here, are due to sampling error or the difference is there in the population, we want to arrive at a conclusion. So when I say that gender and employment category are not independent, I'm rejecting the null hypothesis. Okay, writing null hypothesis again. Gender and employment category are independent. It means category has nothing to do with gender. If I reject this, I prove that there is gender bias. Okay, but here, in order to prove the gender bias, I need to have certain statistical tests. Okay, and as we have already written in your notebook, when you are dealing with two category variables, the relevant statistical test applicable is chi-square. So we have chi-square as well, and in chi-square you have a p-value here. P-value here again, p-value is less than 0.05. Okay, rather it is 0.000. It means based on the sample of 474, if you conclude that there is a gender bias in terms of category, in terms of positions, you are 100% correct. There are no chance of committing an error. If somebody repeat the study 10 times, 100 times, he will come to the same conclusion. If somebody conduct the census, collecting data from all 60,000 employees, he will also come to the same conclusion. So you are 100% confident. Whereas you are ready with 95% confidence, but software tells you that you are 100% confident. So here the p-value is less than 0.05. So you reject the null hypothesis that employment category and gender are independent. You reject it. So it is proved that yes, there is a gender bias. Got a point? Okay, so gender bias is again proved in this case. Okay, so this is second one, chi-square. Any question with anybody at this stage? Please unmute yourself and ask before you proceed, because we need to cover up two more analysis. Or you can write in the chat box. Let me look at the chat box. Something is possible. Whether in doctrinal research hypothesis research questions, doctrinal research hypothesis and research question both be added. Mr. Paul, we normally have objective specified in the research, then hypothesis to be specified in the research, and if it is a research paper, nowadays the trend is we write only null hypothesis. Okay, but you can write both null hypothesis as well as alternative hypothesis. Okay, T interpretations. In that case, interpretation will be significant as 0. Yeah. So when we talk about yeah, in this case, Arundhati, yeah, even if you say my p-value, so I'm 99% confident. So even if you say significant as 0.01% level, yes, it is significant. So when something is significant at p-value of 0.000, it means even less than that, you are 100% confident. Okay, so interpretation is perfect. Okay, so let's move ahead. So I will go to data file again. Here, third one. I have got two variables, one salary and beginning salary. Or let's talk of slightly different, salary and education. Now, what theory said? Theory said those who are highly educated are expected to get higher salaries. Education is influenced by salary. I want to check whether education and salary are they significantly correlated or not. So here I got two variables: education, which can take any value, salary, which can take any value. I'm talking about two continuous variables. And when you're talking about two continuous variables, the relevant statistical test that we have listed here is correlation. So want to find out whether these two are moving in the same direction or moving in opposite direction. So when the education increases, salary also increases. With decreasing education, salary also decreases, or maybe a reverse the case where we do a correlation and going beyond. If you want to estimate, suppose after doing correlation, suppose let's go for correlation. So analyze, we have correlate and we have bivariate correlations. Has selected education, has selected salary. You might have studied Pearson, okay, Kendall and Spearman, so not getting into those details as of now. Mean and standard deviation if you need. This is a flag significant correlation. This is a correlation value. Just make it, yeah. So this is a correlation value. Now what does it tell me? One, this is a correlation matrix. So education level and education. So the same variable correlation is 1. Correlation between current salary and current salary is 1. This, sorry, let me annotate so make it much more clear. Yeah, this value, okay, and this two value are equal. But this value indicate the correlation between education and salary, and this is between salary and education. So diagonal values are the same. Okay, so here the correlation is 0.661. What does it mean? 661 means 1, the sign is positive. So there is positive correlation between education and salary. So those with a higher education are getting higher salary. Number 1. Second, the value. Value is positive. So more than 0.5. So if it is more than 0.5, we say strong correlation. So there is positive correlation, there is strong correlation. But whether this correlation is significant or not, because it may possible that in sample you have a correlation, but in population there may not be correlation. Okay, so whether the correlation is there in the population or not, for that you have a significant value also here. So we said correlation is significant at 0.01% level. It means, and I have got even my p value 0.000. Okay, it means there is positive, strong positive and significant correlation. So it means this correlation is there in the population. That's why this correlation is there in the sample. Okay, this is what a correlation means. And going beyond that, if I want to do an estimation, I want to find out the salary of some employee based on education. If education is known to me, can I estimate the salary? When the question of estimation comes in, you go with a regression analysis. Okay, so just to talk about a bit. So we have regression, and we got a simple linear regression. For me, current salary depends on education. Nothing doing much, simply pressing OK. Now I got the result. Okay, this is R is nothing but a correlation value. This is a correlation. This is R square. It means what percentage of education, what percentage of salary depends on education. So it is 0.436. It means 43% variation in salary is because of education. We call it model fit. So my model explains at 43.6%. So fluctuation in salary, out of those fluctuation in salary, 43% fluctuation is because of education. Still, there is a large chunk of salary which is not because of education, but because of some other variable. If you want to include that, it becomes a multiple regression. Now, whether your model is significant or not, for that you do ANOVA, and this is a p value which is significant, so your model is significant. What is your regression equation? Your regression equation is available here. This is constant. Okay, and this is education level. So here, my regression equation, if I want to write an equation, y is equal to a plus bx. Okay, so here, current salary is a function of education. Function of education. So my regression equation becomes current salary is equal to this minus 18331 plus 3909 into education. So if somebody comes and tells me that I have got education of say 15 years, somebody with the 15 years of education, what will be his salary? His salary will be 3909 into 15 minus 18331. So I have got entire regression equation. For that, you can do this kind of analysis. Okay. Okay. Running short of time, going a bit fast now. Yeah, going to data. Now suppose I wanted to find out the salary across job category. So I've got two variables. One is salary and other is employment category. Now here I have got salary, which is a continuous variable. I have got job cat, which is a category variable. But here in this category variable, there are more than two categories. So when you got more than two category, you run a statistical test that is called ANOVA, analysis of variance, which is nothing but an F test. Okay, F test, how it is done and how do we interpret. So I'll go to analyze, compare mean. There is one way ANOVA options available here. I need to decide I am my dependent variable. So now for me, the model says that salary depends on category. So your salary depends on whether you are a manager, supervisor or clerk. So employment category here. Okay. And here we got some options available here. So in option, I am clicking descriptives because I need main salaries and everything as well. There's another option here. I'll explain it later on. That's called post hoc. Some of you may be aware. Post hoc, and there are various post hoc available. Most prominently used is the Tucky test. So clicking here and just pressing OK. What it will tell you? Now these are my descriptors. These are the main values. So clerical, there are 369 clerk, average salary of 27,000. Custodial, that is supervisor, average salary 30,000. Manager, average salary 63,000. So now I got three averages. In case of gender, we had two averages. In case we got three averages, we cannot use T test, so we have to use F test, which is nothing but an ANOVA. So we got average salary of clerk $27,000, custodial 30,000, manager 63,000. Now here my null hypothesis is average salary do not differ significant. There is no significant difference rather at zero. There is no significant difference in the salary across various employment category. So my null hypothesis कि ये तीनों कैटेगरी के सैलरी में डिफरेंस नहीं है. There is no difference in the salary of clerk, custodial and manager. If this is rejected, it means there is a difference. So here salary of clerk is equal to salary of custodial is equal to salary of manager. This is my null hypothesis. And these three are not equal is my alternative hypothesis. But when I look at the data, it seems 27, 30 and 63 seems a difference. So my null seems to be rejected. But whether it is rejected or not, we need a statistical test. And for us, this statistical test is ANOVA. And in ANOVA, I have got my p-value here. P-value here. Okay, so here the p-value here is less than 0.05. So we prove that yes, my H0 is rejected. It means salary depends on a category. Whether you are a clerk, custodial or manager, it's going to affect your salary. So it means these three means are not equal. But here, it may be possible that clerk and custodial may be equal. Now, which of these three categories differs compared to others? Okay, I can further analysis. That further analysis is what we call post hoc. Some of you may try it out, post hoc. And what post hoc does, just to bring it to a slightly upper level. Yeah, this one. Okay, this is a post hoc test. And what post hoc does, clerk and custodial, they are compared. So you are comparing the salary of clerk and custodial, and this is your P value. Look this, 0.277. It means if I say that clerk and custodials are getting different salaries, internal comparison, then I'll make an error, and the probability of that error is 27%. I am ready to accept up to 5%. This is much more than 5%. So I do not reject it and say there is no significant difference in the salaries of clerk and custodian. So salary of clerk and custodian do not differ significantly. But when I look at the data, okay, the data tells me that yes, the clerks are getting slightly higher than the custodian. So clerks were getting 27,000, custodians were getting 30,000, but the statistics say that there is no difference. This is just because of sampling error. Difference is not significant. But when I compare clerk and manager, the difference is significant. Similarly, custodial with clerk, no significant difference. But when I compare manager with clerk, both are rejected. So the post hoc table tells you, that manager salary is different, but there is no significant difference in the salary of clerk and custodian. So whether you are a clerk in this company or supervisor, so when you are promoted from clerk to supervisor, your salary do not change much. Your salary changes when you are promoted to a manager, because then there are likely chance of you getting higher salary of 63,000 plus. So homogeneous group subset. So the post hoc test, what Tacitus does is it divides your category into homogeneous group. So you've got two groups. Group number one, clerk and custodian. It means clerk and custodians are in the same group, like cluster. Somebody might be aware about cluster knowledge. One cluster consists of clerk and custodian. Other cluster is managers. So we arrive at the conclusion that yes, salary of manager are different when we compare with the salary of supervisor. Okay, Pratyusha is writing ANOVA steps again. So let me clear this drawing. Let me close the annotations. Again, I'm going to give you my YouTube channel link as well, where this ANOVA entire video with the same data file is available. Still, so we have compare mean, one way ANOVA. Select the dependent variable, select the factor, click on option, select descriptive, click on post hoc, select Tacitus, press continue, and OK, you'll have the result. Okay, this is how we do hypothesis testing. What we covered is just 5% of hypothesis testing, nothing beyond that. I'll go back to the presentation again, just for the sake of reference. Your hypothesis, when you write, it has to be clear and precise. Okay, it has to be capable of being tested. It should show the relationship between two variables, at least two variables. So when you go for hypothesis testing, be clear in terms of which variable you want to analyze, which two column you want to analyze. At least two columns that is required. It has to be very specific. It has to be specified in simple form. It must be consistent with the known facts. It should be such which can be tested within a limited time, and it gives rise to need for explanation. This is very important, because what we did right now is a statistical tool. As a researcher, your role goes beyond that. If it is rejected, why it is rejected? What is the reason? If it is not rejected, why it is not rejected? Give justification. Think of a justification. before justification, whatever you did is just a technical exercise. So be clear with that. This is null hypothesis alternate. You can very well check it up. Something that we did. Okay, these are the process, and yeah, this is the last slide where my blog is mentioned. So just go to your internet, Google Chrome, and say drkishore.wordpress.com. This is my website. A lot of inputs available there. And if you are searching on YouTube, just go to YouTube and put on Dr. Kishore Bhanushali. You will come across my link, and that link has many videos related to statistical analysis, hypothesis testing, p-value. If you are looking at some specific video related to any specific analysis, you can very well just put the message in this channel message itself as a comment, or you can just drop in a mail. If you go to my blog, drkishore.wordpress.com, my contact email, contact number, email ID, everything is mentioned there. Feel free to get in touch with me in hypothesis testing or anything related to research methodology. If you're looking at specific content, just drop in a message, and we'll prepare a video to be uploaded at YouTube channel so that it benefit to everyone. And still we have around 5 minutes. So yeah, my email ID. It is mentioned on my blog as well, but still on the first page, it is kishore@karnavati-university.edu.in, or I'm just writing in a chat box. This is my personal ID. Yeah, and this is the mobile number if you want to have something. But if you want to some discussion for anything related to research, I'll suggest call me after 7 p.m. because during the daytime it will be difficult for us to justify the discussion. So very well. For any questions, I'm here. Okay, Chatterjee sir is here.
Hi, Dr. Kishore.
Yeah, how are you, sir?
Nice discussions.
Yeah, thank you. So
they have learnt a lot.
4 minutes, and if anybody has anything to discuss, feel free. I'll be sharing this data file and also the presentation. Okay, so anybody want to have? I'll advise the Dr. Tapan and Subhasis sir to share that data with everyone. Yes,
distribute this to us. Please share the files or PPT.
Yeah, it will be shared.
Yeah,
it will be shared. I'll share with Dr. Tarun and Subhasis sir.
Okay, so thank you.
Yeah, thank you.
Thank you, sir. Dr. Kishore, thank you very much.
Thank you, sir.
Sir, thank you very much from the Research and Development Cell, ICFAI University, Tripura, and from the entire ICFAI family. Just kindly accept our heartiest thanks, and what you have taught to our research scholars and faculty members, definitely they have benefited, and I hope in future we will be in touch and you will help us and we will accept our invitation again. Thank you very much, sir.
Surely. I'm also part of ICFAI family because I worked with ICFAI for nearly 3.5 years.
Okay, sir.
IBS Ahmedabad.
Oh, okay.
So initial
okay.
career I had with ICFAI. So I had a separate soft corner for ICFAI, and Subhasis sir, of course,
yes,
good friend of mine.
We both are
yes, yes. Yeah. It was a very nice presentation, sir. I hope our participants will benefit from it.
Yeah. Thank you. Thanks a lot.
Thank you, sir.
Thank you, sir.
Thank you so much, sir.
Thank you. Thank you so much.
Thank you so much, sir.